All right, coders. You probably think you have a lot of stuff to type in. It's not really the case. You don't have too much to do. What I'm going to do is I actually have already done it all. What I'm going to do is I'm going to highlight the things that you need to add or change, then follow along. And after I tell you what to do, pause it, do it, and then continue the video. Okay? And I'll explain what it does as we go along. Okay, so number one is we have to add this line right here. What that does is it makes it so that we can have a magnet sensor. We need a magnet in the handle to tell it when to start blinking the lights. Okay, so just add that one in there. Okay, this one was already there. This one's already there. You will have to change this number from, it used to be 2, now it's going to be 8, because now you have 8 lights. Notice that the array has gotten bigger to compensate as well. Now, if for some weird reason your electrical person is having a hard time getting a wire to work with one of these pins, so let's say number 2, somebody the year before or your electrical person accidentally broke off a wire inside of there and we haven't had a chance to fix it, there are other pins that are available. Pin 9 is available. Actually not 9, sorry, 9 is used for color. Then 8 and then 12 and 13 are available. So let's say they can't use 2, so they're using 8. You would just change this number to 8 if they plugged it into there. They may just shift everything down. You just skip 2 and go 3, 4, 5, 6, 7, then 8. So double check with your electrical person, make sure that these are the slots that everything is going into, okay, the pins in the Arduino. All right, so if anything changes there, all you have to do is change it here and it's fixed. These are all the same. Let me double check my notes here. So, all right, the next thing, it's not for a while. I'm going to come down to just after your fade out. So it'll be right before your void setup. Okay, so just click right above your void setup after the last curly bracket and type in this hashtag include test. You don't have to type out this, but this is here to remind me to tell you that once you type this in, you cannot verify your code until you have actually included a image file. And I taught the mechanical people how to make one, and I told them to call it test. So that's what I'm using here. If they did a different name, you have to type the exact same name. All right, so as soon as they give you an image, you'll be able to put it in here, and I'll show you how in a minute. So hashtag include test.c or whatever image it is. You will probably have more than one image, and so if that's the case, that's what I forgot to do. So that'll be one of them, and then you'll have another one, and all you'd have to do is just highlight that. See, you did your name, right? So whatever your name is, .c, and see, probably have somebody else in your group. So everybody's going to be giving you images, and you're going to have to keep putting in their stuff. Okay, so make sure name B, name A, name B. All right, so I'm going to tell you, as well as I told the other person, do not have any spaces or weird characters in these file names. Okay, it will freak out. All right, so keep them simple. Don't have any spaces, just letters. Okay, capital and lowercase letters, that's it. Okay, and so you can only have one of these active at a time. Let's say you don't want to show the test anymore. You comment that one out and bring in another one, okay? So only have one active at a time. You can have them all here, only let one go at a time. Anyway, so that's that one. Next is this right here, the get pixel. Okay, so you don't have to type this in. Let me pause right here and show you how to get that, so you don't have to type it all in. Okay, so I'm going to minimize this, and notice right here I have an image. Let's say either you made one or your mechanical person gave you an image. It'll look just like this. You'll probably save it in your M drive or whatever. I just have it here so you can see it. I'm going to open it up. It looks like this inside of Paint, not Paint, but Paint.net. They're different. Okay, if you open it up in Paint, it'll be tiny and you can't zoom in as big as you can in Paint.net. Anyhow, what you need to do is open up a Java file that we wrote, and this is only available through us. So anyway, I have people that might be watching this that aren't in my class, so I'll find a way to make this available to other people, but I'll have to ask the creator first. Anyway, so it's called the Java file called image to see.jar. Okay, so I'm going to open that up, and it just looks real simple. It's just like this. Okay, so first you have to browse for where your image is. Mine's on my desktop, so when I say browse, I'm going to go all the way up here to my desktop. You have to know where yours is. It's not going to be where mine is unless you save it on the desktop. Okay, so I'm going to desktop, and I just say open. Not open. I have to say that one first, and then open. Okay, now if you look at this, okay, I'm going to make this bigger. If you look at this, it takes that image, and every single pixel is now 3 numbers. So the first thing, it was just all black, so it's just 0, 0, 0. And then the next pixel gets turned into 3 numbers, 0, 0, 0, so on and so forth. It finally gets to the point where, oh, here's something that has color. Okay, and if you look at that, there's the T, the E, the S, and the T again. Okay, and they're all different colors, so the numbers change. And then there's just a ton of zeros because I just did that real fast. Anyway, if you look right here, look at this. Copy this function into your code. There it is, all typed out, ready to go. Don't get it from here yet. We're going to save it first. So save as, and this is where you have to be very careful. You have to be precise where you save it. Okay, so my Arduino file, I know where this is saved. Yours is saved somewhere else, so you have to know where it's saved. If you don't know where it's saved, go File, Save As, and look and remember, okay? So go there, figure out where you saved it, because I have a lot of students that forget where they save things. Anyway, so I saved mine in my M drive, which we have at our school, right? So yours will have your student number, M drive, and Arduino creates an Arduino folder. So if you haven't been paying attention, you just hit save, it's probably in there. So in an Arduino folder, and I have the one that I'm working on right now, I called it right here, final code. Okay, so which one of these is called final code? There we go. Inside of there, you don't see it right now, but that's where your Arduino file is saved. This is just looking for other things. Anyway, so here's the name, test.c, and I'm going to save it in the same folder. Boom, done. Now, the test to see if test worked is to see if it actually makes a tab up here that says test or whatever name your file is. Okay, now you don't see it right away, and I don't know how to refresh this, so here's how we do it. Make sure it's saved. So file, save. I know mine is, but I'm just going to show you that. So file, save. I'm going to get out of it, and I'm going to go right back into Arduino, and you'll see that, oh, look at that. There it is. It's stuck in there. So if you don't see it, then you did it wrong. Okay? So make sure it's right. If you named it with a space or something, it probably won't show up. Okay? So make sure that everything is the same. Okay, so that right there, again, make sure this and this are spelled the same way. Everything's the same. You only have one of them active. Then come inside C and then highlight all the way down to here. Copy, paste over, boom, done. Okay? So you do not have to type this. So those of you who paused the video too early and typed it, sorry, I should have said it a little bit earlier. Anyway, this you have to type. This is the function. It doesn't do it yet. This is saying what to do when we say wait for a magnet. It's going to wait for the sensor to go low and then high again. Okay. The sensor actually sends a high value when there's no magnet and a low value when there is a magnet. The way that the Hall effect sensor works is that there's electricity running through it, but whenever there's a magnet near it, it actually coaxes some of the current to move away, and then it drops down. So that's kind of how it reads it. So it's constantly looking at that little flow of electricity. And as soon as the magnet goes near it, drops it down. So we wait for it to go high, then low. So as soon as the magnet has passed by the sensor and it sees both high and low, then it's going to go. So while it's less than 600, it's going to sit there and do nothing. That's why there's nothing here. It's doing nothing. And then less than 400 or greater than 400 do nothing, but it has to wait for that shift to happen before it moves on. So it's just a wait thing. It's not doing anything while it's waiting, but it has to wait for both of those things to happen in a row. We already did this. Okay, so where am I? Let me double check. Next. Okay. Because we have a magnet sensor, we have to activate it. So first you make it an input, and digital write high is just sending electricity through it. Okay, so that's just making it run. Let's see. All of our fade in and fade outs are regular. We already did those in previous videos. Void loop. This is where your program is, and that's it right there. Because we did all those functions and all that stuff up there, this is all we have to do. Okay. And I've changed it a little bit from what I was taught. Hopefully this isn't doing it too weird, but anyway, I like it this way. It makes sense to me. So you're waiting for the magnet to go by, and then you're looking at your image. Your image is made of columns and rows. So because it's spinning by, I'm going to go this way. So it's spinning by, and it's going to blink, blink, blink all the way down for column 1. Then it's going to do column 2. But each column, it has to do every single row. So we do the column first. We do the first column, all the lights. Then the second column, all the lights. So that's why we have column first. And the image.width, this right here, image.width, that's going inside here and getting the width, which is 64. So if somebody designs an image that's less than 64, it will find it. Okay, so this is telling it how wide your image is, and it's going through all of those one at a time. And then for every single image, we're going through and looking at the rows. Okay, so n rows is 8, but if for some reason you add more lights or take away lights, this will take care of it, as long as you, at the very top of your code, tell it, hey, I only have 7 lights or I have 10 lights, but then you have to change how many row pins you have. All right. Okay. So you tell it, it starts and it just goes from column 1, row 1. So the very top corner, I have to think backwards because you're looking at me the other way. So very top left corner, because you're reading left to right, right? Anyway, so top left corner and working its way down. So, and that's what rows are doing. They're going down. And so for each row, you have to turn on that LED. So if you're on row 0, it's going to turn on LED 0, which is the one at the top. And then you're going to use your color mix, and you're going to go and you're going to get pixel. Now, that's the one we just copy pasted, so I need to explain it better. Get pixel, and you need to know what row and column you are and what color. So row column red, row column green, row column blue. That's the only thing that's different in each of these is the color. Okay, why does it need to do it 3 times? That's because for every single pixel, there are 3 numbers. Okay, now, so it turns them all on, and then it's going to wait 200 microseconds. This is going to be booking it, okay? 200 microseconds. You got to spell it out like that. Don't forget your capital M. It has to change colors. Anyway, so 200 microseconds. Now, if you change this number to a lower number, you have to spin it faster. If you have a higher number, then you spin it slower. Right? Higher, yeah, slower. But with my testing, I found 200 to be really good. And then after they've all shined for that long, you turn them all off. And then you turn off that LED, because if you leave that LED on and you go to the next one, then that's going to carry the color to the next light, or it's going to leave that light on, and they'll both be the same color there for a little bit. So don't forget to turn off your LED, and then close parentheses. Now let me go up to the get pixel. Please don't stop the video. You want to understand this. I want you to teach everybody else how this works. So get pixel. Now, what is different with this function than any other function? It doesn't have the word void. Why? It's because every single other time we've been telling the lights to do something. We haven't asked the light a question. We haven't said, what is this number? So what does int mean? It means an integer. So I'm asking it to find a number. Where am I asking it to find a number? I'm asking it to find one of these numbers. I have to say int to say, go get me a number. If I say void, it's not going to return anything. It's going to go to a certain spot and say, oh, I got there. You didn't tell me to give you anything. So what do I counted to that point in your array. That's it. It's like so a function where I just tell you to do something, I would just say jump. Okay, now if I wanted to tell you exactly how far to jump, I would put it here. I have an integer that would have distance, and I'd say how far to jump. Now, if I asked you to jump and tell me what number you landed on, then I gotta ask, hey, tell me what number you got on, and that's what this return means. Okay, so it's returning back the image, and this right here, if you really analyze it and you look at this is counting to the exact right number. Once it knows what row and column and color you're on, it knows how far to jump in this array to get to the right number. So let me know if you can figure that out, or let your teacher know, and kind of see if you can't explain it and understand how this works, because this is really cool. And if you type it wrong, it does weird things. So this is why we decided to make it so that you just copy paste it in. Anyway, all right. Okay, so now that you know how that works, let's come back down here and see. You remember color mix from a long time ago. Color mix only needed 3 numbers, 3 integers. And guess what? I'm calling that function 3 times. Okay, so you're doing every single one of them and every single color by just calling that function 3 times, and each time it counts just a little bit further in the array. Do you see the red, green, blue? What do they equal? 0, 1, and 2. And so if you go back up here and you look at that thing, index plus color, that means it goes to the right section, and then if it's red, it's already on that number. If it's green, moves over 1. Sorry, I'm going the wrong way in the video. Okay, it moves over 1, and then if it's Blue moves over 2. And boom, 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 got boom, 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 sorry, that way. And it gets all of the letters, numbers. Okay, sorry, I'm getting confused here. Now, turns it off, boom, done. This is everything. It's basically done. I'm going to try, I put it on mine. I don't know if you can even see it. Probably not with the resolution that I have going here. But anyway, it says test. Maybe from a distance. Anyway. It might be going the wrong way too. Anyway, so there's that. And what you need to do is design some images for you, but you are in charge of converting everybody's image into an array and putting them in the same folder. When you're done, you should have a tab that says whatever you called your code. You can call it final code if you want. And then you should have 6 more tabs with different names of all the different images. Okay? And I think that's it. We are done with the project. I hope you have fun with it. And I hope it's not too complicated, because it's actually a really cool project.